Hi guys, and welcome to section 4 of building AI models using Autogon AI. So in section 4, we're going to be looking at supervised learning algorithms, and this course offers an in-depth exploration of supervised learning algorithms focused on both theoretical underpinnings and practical applications in various domains. It is designed for students, researchers, and practitioners with basic understanding of machine learning concepts. Okay, so table of contents, we're going to look through machine learning workflow. We're going to look at the supervised learning, types of supervised learning, key concepts and techniques, types of regression algorithm. We're going to look deep into the regression and classification algorithm. We'll look at both the NoCode routes and we'll look at the AutoML route. We'll look at inferencing a regression model via an API call. We're also going to look at supervised learning regressions using Autogon Studio and supervised learning classification using Autogon Studio. Okay, so machine learning workflow. So it's very interesting that you understand that. So there's a process to building machine learning models from the section 1 being get data, section 2 clean, prepare, and manipulate data. So we've spent the last section, that's section 3 of Autogon NoCode course. We've spent more time on cleaning data and manipulating data. So the next is training models, testing data, using test data to hit on these models, and then we continue to improve. Yes, so improvement in now begin to check out some more algorithms, tune your hyperparameters, play with some more hyperparameters until you get the desired model accuracy that you're after. But yes, this is a basic machine learning workflow. Okay, so supervised learning. So it's a very interesting journey we've gone so far, and yes, and we are going way more in. Super interesting to have you here. Okay, supervised learning is a type of machine learning in which algorithms learns to make predictions or decisions based on labeled training data. Labeled training data. So take note of this labeled training data. In supervised learning, the algorithm is provided with a data set that includes both input features and corresponding target variables or outputs. And the primary goal is for the algorithm to learn a mapping from inputs to outputs so that it can make accurate predictions or classifications on new and unseen data. Now, if you look at this image to the right, yes, so tomatoes, carrot, and green pepper, bell pepper. Yes, so this is a labeled data. Here are the labels: carrot, tomato, bell pepper. Yes, I can see label data. The training data set is used in supervised learning, consists of pairs of input data and their corresponding correct output labels. And you can see, and these are their correct output labels. And so just like we looked at in time past, we looked at banking data sets and if the customer was going to deposit yes or no. So that yes or no is a labeled data. Yes, so when you are discussing independent variable and dependent variable, that dependent variable is the target variable. That target variable is actually a labeled data. So supervised learning is when you're given so like a bank has a data set of different financial transactions, and in time past they've had a couple of fraudulent transactions, and the bank has been able to label each of those transactions. Oh, this was fraudulent, this was not fraudulent, this was fraudulent, this was not fraudulent. The ability to label such transaction is a supervised learning model we need to build. So if you're being tasked with building a model for such bank, you'll be building a model that understands the relationship between the transaction activities and the labeling. So the model will try to understand all the coefficients, all the correlations between those two, the independent variable and the dependent variable, that when a new transaction is coming into the bank, your AI model can predict if that transaction is actually a fraudulent transaction or not a fraudulent transaction from known history. So yeah, this is AI leveraging history to make decisions. So supervised learning is when you train AI models to leverage history to make decisions. So that's supervised learning, like in GV. So we have the label data, we have the labels, and it goes through the model training phase and predictions. And you can see the predictions is coming from these three labels. Oh, it's a tomatoes. Oh, it's a bell pepper. Oh, it's a carrot. So supervised learning can be categorized into two main types based on the nature of the target variables. So that's the target variables, and you need to take note of this. So when you have a dependent variable, what is the nature of the dependent variable? And it can be classified into two main parts. And types of supervised learning: classification and regression. Yes, we are making interesting progress in this course, and I congratulate you if you've gotten to this point. So classification. In classification, the target variable is categorical or discrete, meaning it belongs to a specific class or category. The goal is to assign input data point to one of these predefined classes or categories. So now, if you look at the right, now this is a bank dataset. The name of the customer, the loan amount, if the loan was repaid or not, and if it was a fraudulent transaction or not. You can see 1 fraudulent, 0 non-fraudulent, 1 fraudulent, 1 fraudulent, 0. So they were able to classify this 0 non-fraudulent, 1 fraudulent. Now, this is a classification algorithm. So the bank has told us for this independent variable, name, loan amount, and loan repaid, deduce the dependent variable for a new customer that comes in. Let's know when we get fraudulent loan request or not. So if you're going to build a model that understands each of these independent variable in relation to this dependent variable, also known as the target variable, and this target variable is of a categorical variable like this, then you are building a classification model. Then for a regression, in regression, the target variable is continuous and numerical. Understand the difference. Classification is categorical and discrete. Regression is continuous and numerical, meaning it can take on a range of values. Exactly. So you can see these are continuous values. Oh, advertisement, budget, and sales. So this is for a business, and they had an advertising budget of $90, and that month they got a revenue from the customers that came in, the new customers that came in, $1,000. And when they increased the advertisement budget to 120, they got 1,300. 150, they got 1,800. $100, they got 1,200. $130, they got 1,380. So they want to know, if we invest $200, how much are we going to get in sales? This is a regression problem. And yes, these are the two core types of supervised learning: classification and regression. Okay, so key concepts and techniques. So there's some key concepts and techniques you need to always have in your mind when you're building models. Overfitting and underfitting. Overfitting occurs when a model learns the training data so well, including its noise and outliers, and performs poorly on new data. Underfitting happens when the model is too simple to learn and to learn the underlying structure of the data. So you can see this particular line. Yes, you can see this particular line, and that's the line of the model, and this is the data. So the model is unable to model the data. You can see when the model is too simple to learn the underlying structure of the data. So each of these things are the data patterns. Now you can see this is a good fit, where you can see the model was able to a good point, model the flow of the data. Yes, it models the flow of the data. Yes, there are margins of error. You can see this is data point, and and this is where the model is predicting. This is under data point, this is under data point. So there are little margins of error, but this is a good fit. Yes, but overfitted. So when your model knows your data too well, like too well, we can see overfitting occurs when your model learns the training data too well, including the noise and the outliers, and performs poorly on new data. So it learns that training data too well, and when you give it a new data, it just performs so poorly on it. So overfitting, and take note of overfitting. And when we get into deep learning and you're specifying the number of epochs, sometimes the more the epochs you specify, and so the more the model understands and learns the data set too well. For example, a data set of cat and dog, it learns it too well that if it sees a new image of cat, it's unable to identify that. Okay, so cross validation. This is a technique used to assess the generalizability of the model. The data is divided into several subsets, and the model is trained and tested on different combinations of this subset. So the whole key thing around cross validation is breaking your data sets into subsets. So the algorithm that gets this done, it breaks your data set into different subsets, and then you can see iteration 1, the training set, test set, iteration 2, the training set, test set, and for every single iteration we're getting the error value, and exactly. So this is what happens in cross validation. So if you are making use of Autogon Studio Wizard, it automatically takes care of this for you automatically, same as the overfitting and underfitting. Model evaluation metrics. Different metrics are used to evaluate the performance of models in supervised learning, such as accuracy, precision, recall, F1 score for classification tasks, and mean square error, mean absolute error for regression tasks. Take note of each of these metrics. So accuracy, precision, recall, F1 score for classification tasks, mean square error, mean absolute error for regression tasks. Now, if you look at this image here, you can see it's already broken down for you. Regression, classification, unsupervised model, and others. So you can see regression, each of these metrics has been brought out, and classification, you can see the following metrics, and unsupervised models, you see the following metrics. You see more of these metrics more often as you are now an AI engineer, and yes, and others, you can see some more other metrics. Hyperparameter tuning. Many supervised learning algorithms have hyperparameters that need to be set before the learning process begins. Hyperparameter tuning involves finding the optimal set of parameters for a given model. Yes. So the session before now, we were playing with a random forest classification, and if you notice, the metric that we're specifying, the hyperparameter we specified was Gini, Gini. There are also other hyperparameters that we can also specify. So those are playing with hyperparameters, and there are safe ways you can play with hyperparameters to get the best model accuracy for your data set. Good. And yes, if you're using Autogon Studio Wizard, you don't need to play with hyperparameter. That is automatically done for you. So key concepts and techniques. So feature importance. Yes, feature importance refers to techniques used to identify and rank importance of input features in predicting target variable. Take note of this. Input features in predicting target variable. So when we've built our model, you see feature importance. So feature importance map there is trying to tell you which of the input features, which of the column names, which of the data attributes is of high importance to the value of the target variable. That's the dependent variable. The independent variable, the dependent variable. So yes, By the time you understand those input features, and you can then translate it into your business logic and make very sound business decisions. Error plots. Error plots are visual representations used to understand the patterns in prediction errors made by models. Now, there are two things you need to take note of for error plot: the identity line and the best fitting line. Now you can see this graph here. This is the best fit and this is the identity line. Identity line indicates where predicted values are exactly equal to actual values, showing perfect prediction accuracy. So where prediction values are equal to actual values, that's the identity line. You can see it's lighter shade, and this is the identity line. Sorry, lighter shade, yes, this is identity line, yes. And best fit line shows the model's optimal approximation of the data, balancing fit accuracy and model complexity, particularly in lasso regression. Yes, lasso regression. A significant gap between these lines suggests reduced model accuracy. So the wider the gap between these two lines shows lower accuracy. You can see there's some gap here already, and that's why the R squared score is 0.628. So if you are getting 0.9, you see there's a more closer gap between these two things, between these two lines, and it models the shape of the data. And if you're getting 100%, you can see these two lines will collapse in one. So a significant gap between these lines suggests reduced model accuracy, potential model inadequacy, risk of overfitting or underfitting, and need to reassess the model. Confusion matrix. Yes, we're getting there. In classification tasks, a confusion matrix visualizes the performance of an algorithm. It shows the count of true positive, true negative, false positive, false negative, true positive, true negative, false positive, false negative. So yes, I've placed a graph here, a small chart here, and yes, the upper region, always have it in mind: upper region positive, lower region negative, upper region positive, lower region negative. So you can see this is the true positive and this is the true negative. So true positive is where it's actually positive and the model predicted it to be positive. True negative, it's actually negative and the model predicted it to be negative. For example, fraud detection is fraud. So the model predicted that it's fraud, it actually is fraud, and the model predicted that it is that it's a fraudulent transaction, and the label data says fraudulent transaction. That's a true positive. True negative, the model predicted that it's a fraudulent transaction, whereas the target variable says it's not a fraudulent transaction. True negative. False positive, it's actually not a fraudulent transaction, and the model predicted it to be fraudulent transaction. And false negative, just like that. So yes, take note of this, and because this actually determines the accuracy of the model. When you sum the true positive and the true positive and the true negative divided by the total of every single prediction, you'll be getting the accuracy of the model. Validation loss. Validation loss is a metric that quantifies the error of a machine learning model on a validation dataset, which is a subset of the data not used in training. So now there's something about the validation loss. The lower your validation loss, the higher your model accuracy. The lower, so it's a way to evaluate model of how well the model generalizes on same data. And yes, the loss can vary depending on your data set. So depending on the data set, so where your model is predicting it, and it depends on the sector you fall in. The margin of error, yes. So where your model is predicting something is $600, and the target variable says that item is actually $601, that's a low loss. But when your model is predicting $600 and the real item target variable is 8,600, that loss is actually very high. Okay. Okay, so there are different types of regression. We'll look at regression first before going into classification. So there's the simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression. So these are the basic ones. So there are more other types of regression, but these are the key common ones you use on your day-to-day. But yes, when you play with the Autogon AI tool, yes, you have access to more other regression. Then the Studio Wizard, yes, as new regression comes in, it's automatically taken care of. It runs multiple regression on your data set and looks for the one with the highest accuracy. Yes. So regression and when to use each algorithm. So we're quickly going to scan through each of these. So linear regression, when you have a continuous target variable and one or more predictor variables, when you want to model a linear relationship between the predictors and the target variable. This item 2 is the core part when you make use of a linear regression. So when your data set has a linear relationship, like the data set we're looking at the beginning, country, age, salary, and when we did a chart, we saw a linear relationship between age and salary. Yes, so the best regression to use for that particular data set is a linear regression. Polynomial regression, when the relationship between the predictors and the targets is non-linear and can be approximated by a polynomial curve. Yes, when you want to capture curve or curvilinear relationships. So let's say rabbit births, and you're looking at the months and rabbit births, and yes, there's just a very non-linear or depletion of the ozone layer and the degree of the depletion. So when you are trying to model something where the variables are of degree of one another, so the depletion is of much higher degrees and it's going in 2x, 3x, and 5x, and so you're trying to understand that degrees and degrees. So that's where polynomial regression comes in. And ridged regression, when multicollinearity, high correlation between predictors, is a concern to prevent overfitting by adding L2 regularization to the linear regression model. Elastic net regression, we have the support vector regression, which is a very beautiful one when you have a continuous target variable and complex non-linear relationship between predictors and the target variable. So you want to have this particular page as a guide when you're working on regressions, especially when you're working through the studio environment, when you have the ability to choose the kind of regression you want to use. But yes, at every point in time, our advice, at every point in time when you're building a model and you want to build a regression, try out multiple regressions after you've feature scaled. If you need to feature scale, bring out multiple regressions. So that's the beautiful thing about Autogon Studio environment. So you bring out multiple regression and connect it to your feature scaler. You run this. When you're done running this, run this, and when you're done, compare the accuracy. that's a good way to go. Okay, so we are going to go the no-code route with regression, and we have 4 data sets to play with on the studio environment. So let's open this data set 1. So I'll visualize data set 1 first on my browser, and while this is opening, I would open data set 1. I'll create a data set and I'll call it regression. Okay, let me put section 4, regression data set 1. Okay, and I'll paste the URL of data set, section 4, regression data set 1. Okay, I think we can also create the other. So this is going to be section 4, paste it, section 4 regression, data set 2, and paste the same thing here, and we'll come again, we'll paste this, and section 4 regression, data set 3, we'll paste this here, and we'll go to the last one, section 4, paste the URL, section 4 data sets regression 4, and paste this here just to save time. Okay, beautiful. And let's visualize dataset 1. Oh, okay, so dataset 1 happens to be the dataset of different companies. Yes, the R&D spend, administration spend, marketing spend, the states in the US where they are, and the profits that they made. And you can see these are continuous values. And yes, you can see these are continuous values. And we have about 49 rows of different companies. So let's look at dataset 2. So dataset 2, I don't really know, but so let's say ATV, AP, RH are all independent variable, and we're trying to determine PE being the dependent variable. And yes, we have rows of 9,567, and this is a company. So sometimes when you find some of these data sets on Kaggle for some companies, the column names have actually been replaced, abstracted. Yes, good. So let's look at dataset 3. Okay, so dataset 3 happens to be, you can see row 9, position, level, and salary. So it just has 9 rows and 3 columns, and yeah, very small dataset, but yes, you can see a very clear gap between salary and level. And this is where you bring in the polynomial linear regression. This is where it outshines if you're wanting to understand the degree exactly, just like we discussed. And if you look at regression dataset 4, and you can see, yes, this years of experience and salary. So this has a linear relationship between each other, the years of experience and salary. Okay, before we dive in building model out of this, okay, so we can start by looking at visualized data sets for each of these data sets. We'll give this some seconds to run. Oh, beautiful. So data set 1, we can see a beautiful heat map, and we can see regions of high correlation. You can see 0.7, 0.7, another 0.7, 0. Okay, you can see these are close to a 1.0, above 0.8 regions of that you need to pay extra attention on. Okay, yes, I like to play with the Calvert plot, and we can see state and R&D spend. So from state and R&D spend, we can see that California has the lowest spend. So state and administration, evenly distributed. State and marketing spend, Florida, yes, Florida businesses does more marketing. State and profits, and you can see Florida region that does more marketing. So there's a relationship between marketing and profit. So okay, state and profit, yes. So Florida does the highest profit, equal to doing the highest marketing spend, and followed by New York. New York has yes. So there's a relationship between marketing and profit, according to this data set. So administration, even distributed, and R&D spend, yes. Florida, so okay, Florida has the highest R&D spend also. So relationship between R&D spend, marketing, and profit according to this data set. So you can look at some more interesting plots, but for me, I like to play between the heat map and the carver plot, especially the carver plot, just to look at specific relationship between each of those columns. Okay, so I'm going to dive deeper into dataset 1. If you look at dataset 1 again, it has 49 rows, and we are after this target variable profit. And don't forget, the goal is the no-code route to regression. So yes, no-code route to regression. So, but specifically going through Studio Wizard here. Once we're done using the no-code routes going through Studio Wizard, we're going to go the no-code route going through Autogon Studio environment. So we would go straight to project, and we'll create section 4. I can just call it section 4 regression. Yes, you can use one project to handle all of those models and build multiple models out of one project. Okay, so we'll launch our Studio Wizard environment, and once we've done this, we'll select dataset, and dataset we're interested is section 4 regression dataset 1, and yes, we are having this open. Okay, so now this feature important you find here is not the one you bank on as to the target variable. So this is relative, like this does not contain the target variable. So this is just feature important based on looking at the entire data set. So we're going to look at another feature of importance based on after we've selected the target variable. So we can see there's no missing value for any of the columns. You can see these are each of the columns. There's no missing value, and median, mean, and max, and yeah. So let's dive right in. So we are building a regression model, and guess what? Profit is the target. Don't forget, profit is the target column, and we'll call this P underscore profits, profits underscore model, and we'll hit on the train. So we'll give this some seconds to run. So it's actually a small data set, about 59 rows or so, so when you're building models, you want to ensure this is just for lecture purpose. You want to ensure you have good amount of data sets so your model can really learn the relationship. Very important. Okay, so you can see we have an R squared score of 0.78, approximately 0.8, which is actually a good one. Then the loss, like I said, the loss actually varies, and this loss of 12802 is a bit high. Yes, it's a bit high. Of 12,808, it's a bit high. So, and the loss is derived from this, the maximum difference you find from here. 12,802. So, okay, so it's not so high. It's not so high. 12802.67. Yeah, so the loss according to this is not so high. Yes. So I needed to show you how you could derive this. So it's not so high. So the loss varies depending on your target variable. So yes, it's not so high. And then we can see we have an R squared of 0.7, about 0.8, and we can see the best fit line and the identity lines are very close as well. So yes, meaning the model is highly performant, and we've just built our first model. And then we can look at the feature of importance, and interestingly R&D spend and marketing spend, especially R&D spend. So this is just very beautiful. So business can make interesting decision. So we can see that R&D spend has the highest feature of importance as to the profit, followed by marketing spend. So investors who are wanting to invest, they will need to spend more, put more eyes on companies who are investing more R&D spend, because there's a high correlation between R&D spend and profit, especially for Florida business. And yes, there's that relationship. But there's that relationship. Okay, so we are going to go ahead to run some predictions. So we look at the data set again. We've built a model, a regression model that understands the relationship between the independent variable, R&D spend, administration, marketing spend, state, and the target variable, profit. And we've built a regression model that understands this. So the investor firm or investors who own this data, they've to ask you to build a model that once a startup applies and they collect this data, they can predict if that startup is going to predict the profits margin of that particular startup. Exactly. And they can predict, so any of this existing startup, peradventure, they continually collect each of these metrics every month. They can predict the profit of any of these existing startups, because they already understand the relationship. We've built a model that understands the relationship between the past data of all of these companies and the relationship between the independent variable and the dependent variable. So now to create a prediction data, we'll come to this prediction. So you can run predictions right here on Studio Wizard. We open these data sets, R&D, administration, marketing spend, and states. You copy this. Let's open Quick Predict. So we'll paste this on Quick Predict, and we separate it by comma. Yes, and we select it on one dimension and generate data sets. If we copy this, we can always visualize this prediction data set. And we can see, I think this is the R&D, marketing, and let's confirm R&D, administration, marketing, and the state. Exactly. And so good thing, we've generated the prediction data set. We can then pass this prediction data set to this test data, and we predict. And we can see what our model is giving us, saying this, for the item we've passed, we're going to get a $192,261,000, $0.828. And if we look at that particular data set, who did we copy? 165, 113. Yeah, we copied this, and 192,261, and we're getting 192,261. So the model predicted this accurately, and this is actually beautiful. Okay, so I'll bring up this. Let's copy these data sets so it can be more visible. Good. Copy the data sets can be more visible, and let's get for this particular record. So you copy all of this. So if you are copying this from the direct CSV data, you don't need to apply comma when you get to data place. So we copy this before this last comma, and we can see these guys, they made a profit of $81,000 thereabouts. So let's generate a prediction data. Let's generate a prediction data out of this. So copy this, and we can make a prediction. I can see 81,005.75, 81,000.76. Can see yes, very accurate. Okay, so let's copy this other guy. We'll copy this other guy, and we come here, we create a prediction data set for it, copy this, and we'll paste this here. Okay, and we can see 72,404.056, and what are we getting here? 65,200. So our model predicted this, but not very accurate. So you can see there is a margin of error, but it's quite close. So that's why we had that margin of error of 12,000. That was like the maximum margin of error. Yes, when we beat the model. Okay, and let's copy one more. So we predict for this, and then we generate the data sets for this. Paste this here, one dimensional, generate the data set for this. We copy this, and we paste it on our test data, and we click on predict, and we got 9514.96, and here it is 49490.75. So yes, take note. Now don't forget we had E0.78 R squared score, and we also had margin of error of about 12,000. Yes, 12,000 thereabouts. So no, not more than 12,000. We had about 120 something thousand. Like that was the maximum margin of error. So yes, so we have a model that is accurate but not very accurate, and accurate by a 0.78, which is a good one. R squared score, but you want to take note. We're having all of these lower accuracies because of the size of our data set. So it's a data set that has about 50 something records, which is not sufficient for the model to greatly understand the correlations. Yes, because the model will still break it down into train test, and by the time you break it down into train test, the size of the train data becomes smaller, and the size of the test data might not be well captured in the train data. Yes, so yeah, try the patterns also. Okay, so what we're going to do, next thing we're going to do is to run this inferencing via quick predict as well, and then we also run this inferencing via postman. Yes, so we would open quick predict. So let's open console on one more page, one more tab, and then we click on this. And so before we enter quick predict, we need to create a pipeline here, and we'll call this p underscore profit underscore model. I'll just call it pipeline underscore profit. Yeah, this is fine. Good. So we've created a pipeline. Let's confirm we have the pipeline. Section 4, and yes, we have the pipeline. So we click on quick predict, select section 4, select the pipeline. Beautiful. We need to enter the data set, generate the data set, and enter the data set. So let's enter I think we've generated some in time past. We can enter the same one we've gotten from here. We'll copy it, and we can paste it here exactly, and we click on run model, and beautiful, 9514, which is similar to what we have here, 9514, but yes, there's a disparity with the 9514, but yeah, it's 49,490. So let's run just one, this guy from New York. So we'll run this guy from New York. Let's create a data set for it, a test data set for it. I will copy this, and we can apply it on this prediction. Don't forget, we selected the project, we selected the pipeline, and we pasted the test data, and we'll click on run for this, and we can see 111313.02. And if you look at the data set, 111313.02, our model did a very good job. Great. So yes, so now we've done this, we are going to hop on to studio environment, and okay, one more thing, we need to build this, we need to inference this model via Postman, and after that we hop on studio environment for this same data set and build a model likewise from there. Okay, so we have our project, we have our pipeline. So I'll quickly launch the Postman environment. I launch the Postman environment. Okay, and yes, I have a sample payload there. I'll update the flow ID. Flow ID is actually your pipeline ID, and to copy it, you have to copy it from here and update the flow ID, which is my pipeline ID. Exactly. Then data set you want to inference. Yes, I want to inference. I'll copy this data set we've used here, and we'll place it on Postman. Okay, and yes, we can send. Oh, invalid API key. Oh, okay. This section 1, I deleted my API key, so I can quickly do that from here. API keys, and I can generate a test API key. Copy this test API key. I come to my authorization section, and I update this. Come back to my body and send this request. And beautiful, we have our prediction. And if I visualize this, you can see 111313, and this is beautiful. And so this is how you can inference. So we inferenced from our Postman, which you can inference from your code. You can copy whatever programming language, if it's Python or that's the beautiful thing about Postman. So yes, you can inference your model, and you can see the milliseconds it took us to inference our model. Hit this, super fast. Yes, so you're using this to carry out a transaction monitoring, and you hit this and super fast you get the response, which is actually beautiful. Okay, so I'll show you how to, because you will not always have to go to the portal to go generate these data sets. You can generate this data set, this inferencing data set, from this other API, and the way to do it is just, so I'll go to the data set. So let's say I have, this is the R&D, I'll paste the R&D. So you paste the values in quotes, and I have I guess marketing spend, and administration spend. So then we copy the states, which is New York. Good. And when we hit on this, you can see the milliseconds it took to generate a prediction data set. So for you to inference that new transaction on Autogon AI, you'll be calling two APIs. You call the API, this particular API, to generate the data set. Then you call this particular API passing the generated data set to inference your model. As simple as that. And yeah, you can see we have our data set here. We can copy our data set link and come straight to pipeline and update data sets, and we inference the model, and you can see the speed of response. Okay, so yes, we got the 111313 prediction, and this is actually beautiful. So we're going to go ahead. And build out same project using the studio environment, same data set on the studio environment. We're going to build a regression algorithm that's going to carry out same prediction on the student environment. So we're going to use we'll use this section 4 regression, and we'll launch the student environment. We'll launch the student environment, and beautiful. So this is the data set of interest, the section 4 regression data set 1, and the first block we're going to drag in is what? The data input block. So click on data input block and we'll select CSV. We'll paste the file of the CSV URL and run this. Give this some seconds so we run. When we click on this, we can visualize. Beautiful. So we have our data sets imported. So the second step we're going to do is we will need to separate independent variable from the dependent variable. So the independent variable R&D spend, administration spend, marketing spend, and state, and the dependent variable is profit. Yes. So we would bring in the feature sampling block, and we'll connect data input to feature sampling. And we'll click on this. The X boundary of the feature sampling, we're going to use slicing. We're not going to use indexing, but we can use either of it because it's a small data set. So we'll enter colon, comma, colon, -1. Refer to the slicing lecture if you still can't remember. And this we're going to enter colon, comma, -1. So colon, this first column meaning all the rows, and this second column means all the column except the -1 means except the last column. So because this is rows and this is the column, and now don't forget that I told you about the range. You dispatch the upper bound, so we're dispatching the -1, and what we are doing here, all this first one says all the rows, and this -1 says for the last column alone. So if we run this, give this some seconds to run. Beautiful. And we can see X value has been generated, which is the independent variable. Y value has been generated, which is the dependent variable. If we double click on the independent variable, we can see, beautiful, we have the independent variable well seated here. And when we double click on the dependent variable Y, we can see the dependent variable well seated here. Beautiful. So the next move we're going to take is column 3. We will need to encode column 3, and what encoding algorithm I'm going to use? We can't use label encoding. We have to use one-hot encoding because we're talking about different countries: New York, California, Florida. Yes, so about 3 countries, which is more than 2. We're going to use the one-hot encoding. So we'll drag in the encoding, data encoding. We'll drag in data encoding. So let's make this, can make this beautiful. Drag in data encoding, and the data encoding will specify one-hot encoding, and the variable x variable pass through, and then what column are we interested in? One-hot encoding, column 3. So yes, we'll pass in column 3 here, and yes, I told you in the last lecture why you need to save the width, and I'm going to show you in this lecture why the width is actually necessary. So we'll call this data encoding, and we can call this country or states. Data encoding, okay, yeah, we can leave it country, and we hit on this, okay, and by the time we double click on the X value, and beautiful, we have one-hot encoded the country region. Now the next thing we're going to do is we are going to, let's open the X dependent variable. We will need to scale column 0, column 1, and column 3. We'll need to scale it. So we'll bring in feature scaling. But before you scale, always remember, before you scale, you need to data split, bring out your train and test data out. So we'll bring in data splitting and we'll bring in feature scaling. Always have that in mind. Before you scale, you bring in your splitting and connect data splitting. You can also connect, so for data splitting, I want to assign 0.2, which is 20%, to the test data set. Leave this as 0. Random states, it's as 0. And we run this. And if we check, give this some seconds. Oh, beautiful. If you can see, our data set has been splitted into train and test sets. So you can see the X value has how many? 50 rows. And if you look at the X train, it has how many? 40 rows. And if you look at the X tests, it has how many? 10 rows. So we've successfully assigned 20% of our data sets to the test and assigned the remaining 80% to the train. Same as the Y train. So you can visualize this even as you follow the course. So you can see 40. Then the next move we're going to make is feature scaling. So we'll apply our feature scaling on the train and use it to transform the test. Very important. We're going to use a min-max scaler. Then yes, we're meant to specify what regions we want to scale, and we're scaling the X train and the X test. So we want to scale 0, 1, 2. So yes, if I'm to specify via index, I'll write 0, 1, 2. And if I'm to specify this via slicing, what would I do? I'd like you to drop it on the comment section. Yes, well, without taking much of your time, you can do column 3. So column 3 is going to say every single thing aside the upper bound, and it gives you 1 to 2. We can try it out here. So if we enter column 3 and then we give it feature scaling underscore weight, and if we run this, okay, so if we double click on the X train, and what did you notice? Everything aside the upper bound has been skipped. So by entering column 3, so everything aside the upper bound, okay, which is beautiful. And yes, you can also enter 0, 1, 2 to scale each of these columns. Okay, so I've gone ahead to bring out all the regression algorithm from what we have here, and yes, I dragged in random. Okay, and I dragged in one more, which is the automated machine learning regression, and I'll tell you why. So yes, I dragged in decision tree, I dragged in support vector machine, and all of these things are found here. And support vector machine regression, so it's as good as dragging like this, and you can always delete it. So I dragged in each of these items, and so let me quickly run you through what I've done. So for decision tree regression, I specified any random name box, decision tree regression underscore model, and then I ran a prediction on the test set. And what is the test set? Let's quickly visualize the test set. I ran a prediction on the test set to get the, so this is the X tests. So if you look at this, 1.0, 0.6, 0.5, 1.0, 0.0, 1.0. So I ran a prediction on this to get what we have here, which is 78239.91. So yes, I ran a prediction on that to get this, and let's see what the model got. So the model is supposed to get 78 to 39.91, and then let's see what it got here. It got 155,752.6, and similar for the next, and so our model predicted that. So the decision tree regression predicted this wrongly. So let's look at similarly for the support vector. So the goal is 78.239, and let's look at the YPRED. And this guy said 120,628, which is very off. So let's look at random forest prediction. So random forest prediction, and random forest predicted 163,822. So let's look at multiple linear regression prediction, and this predicted 186,177. And let's look at this automated regression, and this guy predicted 188,346. Okay, so none of these algorithms here got this correctly. And if we check the Studio Wizard, you can see the algorithm that came out with the highest accuracy. But yes, so extra 3's regressor, good. But mind you, the data set is actually very small, and this is a regression problem. Data set is actually very small. So one of the things that is actually going to greatly improve the accuracy of this particular project is feeding the machine learning algorithm with much more data set. But yes, extra 3's regression actually outperformed every other regression that we've used there on Studio environment. Okay, so the next data set we're going to work on a data set that has a whole lot of records, at least a good number of records, and so we can get some more meaningful accuracy. So let's look at another data set. So data set 2, we have them already. Data set 2, 9567. Let's look at data set 3. Just 9 rows. Let's look at these. Okay, let's work with data set 2. So data set 2, 9,567, and let's work with this. Okay, so we are going to create a new project to handle data set 2, and data set 2 project. Okay, and we'll keep this similar as the description name. Then we're going to launch Studio Wizard environment, and we will load up dataset 2. Load up dataset 2. Okay. Give this some seconds to run, and beautiful. And we can see the dataset number of missing values and everything seems clean. We'll select regression. The goal is to predict the value for PE, given that ATV, AP, RH are the independent variable. Okay, so PE is the target variable, and then we can do PPE underscore model. Yeah, and we'll run this. So we'll give this some seconds to run. So while this is running, we can open similar projects on the Studio environment, dataset 2 project, and we'll launch the Studio environment. You can see this is still running, and we will drag that same dataset, which is dataset 2. We click on dataset list and copy dataset 2. We would apply it, select CSV and apply it here, dataset 2, and run this. So I'll select the variables and visualize the dataset. I can see it has been ported successfully. Let's check. Oh, beautiful. We have an R² score of 95%, approximately 96%. which is very beautiful, and you can see the best fit and the identity lines are very close to each other, so it shows the accuracy is going to be a very good one. And in terms of feature of importance, the column V has the highest, followed by AP, AT, and the RH, so the businesses can pay more attention on each of those columns. Okay, so still on studio environments, let's visualize this data set, and we can see this data set has been imported. So we need to split the independent variable from the dependent variable. That's the number one thing we're going to do. Then the second thing we're going to do, we are going to split the train test from the test set, and we'll now apply feature scaling. So three things we're going to do: feature sampling, data splitting, and feature scaling. Okay, so we'll bring in feature sampling. We'll drag feature sampling, and feature sampling is where we separate independent variable from the dependent variable. So I'll enter colon, comma, colon, -1. If you got this, congrats. Colon, comma, -1. And we run this. We'll give this some seconds to run, and we visualize the X value to be sure. Beautiful. We have it. And we visualize the Y value. Beautiful. We have it. So the next thing we're going to do, we're going to call in the data splitting. Drag the data splitting, and we'll pass data splitting to the feature sampling 0.2 random state of 0. We'll run this. We'll give this some seconds to run. Okay, and let's check the results. We can see our data set has been splitted. We assigned 20% to the test data. So if I go visualize the X train, we would see it has 7,654, which is 80%. And if I visualize the X test, you can see it has the 20%. Beautiful. So the next thing we're going to do is to drag in feature scaling. So feature scaling, beautiful. And we'll scale the X train, apply it, then we fit it on the X train and scale the X test. For the scaler, we can use a standard scaler, and this time around we scale every single thing, colon, and yes, we can then apply. So we need to save the width, so I can just call it feature scaling underscore width, and we'll run this. So beautiful. And let's go visualize this X value. Okay, no, I was supposed to visualize the X train value. Beautiful. Every single thing has been standard scaled. Beautiful. So we would then go ahead to call up regression algorithm. So if we drag in random forest regression. Yes, I like to drag in random forest regression. We also drag in random forest regression predict, and we'll drag in random forest regression metrics. So this time around we're going to call in the metrics. I'll connect random forest regression to the feature scaling. Beautiful. We'll connect random forest predict to this, and we'll connect the metrics to predict, and I'll tell you why. Once the model is done, we will now predict the X test to get the Y pred. Yes, then the metrics is going to validate the Y pred from the Y, and so the Y pred from the Y test, it looks at the both and deduce the accuracy from there. So we'll go ahead to say random forest regression underscore model. Okay, and we can leave this guy at 0. An estimator, we can leave it 5. So this is an hyperparameter. Yes, this and this, you can play with this hyperparameter. Yes, I keep adjusting it to get very good accuracy. And we select defaults. So I'll show you when you can select pipeline. We've not created a pipeline yet, so we'll select defaults. So we'll run this. and when this is done, beautiful, we would supply the random forex underscore model and metric here. We supply R2. Yes, you can always read the description. You can pass in MSE, you can pass in MAE. So R2, we want to see, want to get at the R2. Here is the R2 valuation, and beautiful. So now let's look at metrics under the variables, and we can see we got an accuracy of what? 0.94. But we can see the LGBM regressor gave us a 0.95, approximately 0.96. You can simply play with more regression algorithm here. Decision tree, you can try decision tree regression. Let's try it together. But one thing I like to do is, so aside playing with each of these things, I also like to bring in the automated regression algorithm. So that one runs multiple algorithms similarly to what is done also on the Studio Wizard. But yeah, that of Studio Wizard handles automated data preprocessing and all of the data cleaning automatically as well. So decision tree regression. So let's call in decision tree regression predict. Okay, and decision tree regression metrics. So I'll call this decision tree regression DTR underscore model. So we'll run this, and can also pass similar item here and pass the defaults. Default is because we're using the model that has been built here directly to predict the S-test to get the Y-pred. Okay, and our model prediction has happened. The next thing we're going to do is to supply the model name, and we'll supply R2. So we'll run this. We'll give this some seconds. Good, beautiful. Open variable, and we have a 0.9, which is lower than the random forex regression metric 0.94. Okay, so let's come play with automated machine learning. Automated machine learning. We're dragging this regression automated machine learning. We're dragging regression automated machine learning predicts, and we're dragging regression automated machine learning metrics. Yes, so sometimes I like to also start from here. Then I see most performant algorithms, then I can go play with the hyperparameter also to try to deduce like the highest accuracy. But yeah, this is the beautiful thing about NoCode platform. You can achieve very high accuracy in few seconds, few minutes. Okay, so now this guy is going to run multiple regression algorithms. So we're going to call this automated regression. Okay, regression automated machine learning underscore model. Don't mind me, I just like to follow the first characters. And yes, I'll specify 30 seconds. Each algorithm can run for 30 seconds. Then I can specify 120 as the total wait time that I'm interested in, or I increase it to 150, and I run this. So total wait time of 150 seconds. So let's give this some time to run. And while this is running, we can already update the name of the model, select the default. So as soon as the model is done building, all we need to do is just to fire this button and fire this button. Yeah, beautiful. So let's give this some seconds to run. And once this is done, the next thing we're going to do is we would compare the accuracy we got from the Studio Wizard environment and the accuracy we got from the studio environment. Oh, beautiful, this is done running. Let's fire this. And after we've done that comparison, I'll show you how to build a pipeline on the studio environment. We'll build a pipeline on the studio environment, because sometimes you can engineer your preprocessing and your model build up, and achieve better accuracy on the studio environment over the Studio Wizard environment. So the Studio Wizard environment is just an automated place you just get stuff done. Okay, so yes, you can see we have an R2 score of 0.94, which is beautiful. But yes, the Studio Wizard, we got an accuracy of 0.959, approximately 0.96, which is more beautiful. And you can see the loss of 2.5 here. Okay, we don't have, you can see the mean square error here of 2.8, which is higher than the other error we had there of 2.5. But this is beautiful. Okay, so we're going to go ahead to create a pipeline on both environments. So we'll create a pipeline. Okay, so we'll go ahead to create a pipeline from the Studio Wizard environment. Yes, so if you, so this is Studio Wizard environment, and this is where we'll create our pipeline. So we can specify the name of the pipeline, and this is for dataset 2 underscore pipeline. So you can give this any pipeline name for an organization. Yeah, you can just give it any pipeline name. Good. So we now have a pipeline that has been created. So we can exit the studio environment and we can see a pipeline has been created for dataset 2. Beautiful. We will go ahead also to create a pipeline for the studio environment, and when we are done, we would inference the both ends. So I'm going to introduce something new to every one of you. So beautiful. So to create a pipeline on the studio environment is very simple. From the data inputs, so you need to take note of all the data preprocessing steps that was done. From data inputs, we did feature sampling. From feature sampling, we did data splitting. From data splitting, we did feature scaling. Now, this block does not have to do anything with generation of weights, but the feature scaling has to do with generation of weights. So yes, we're going to take into consideration the feature scaling. So after the data inputs, feature scaling, and after the feature scaling, the model predict. So we'll go ahead by clicking the switcher. So you want to click on the switcher, you'll see this is your function studio, which you can click here to go back, and then you create a pipeline. So now we'll call this studio underscore pipeline, and we'll call this dataset 2. Okay, dataset 2, studio pipeline, and we'll save this. Beautiful. So this is the pipeline editor, and don't forget, there are data preprocessing blocks that keeps weights, that stores weights. Data encoding stores weights, feature scaling stores weight, drop colon, very important, array reshaping, and these are various functions in the pipeline editor. And when you are building a pipeline for a particular data structure of model build-up that you've done, you have to follow the hierarchy, the way the model was built. And for this, from data inputs to feature sampling to data split to feature scaling. So we'll come back to this. Now, input here is going to start from feature scaling. Yes, and that's because every other block before it does not store any weight. So it takes the data sets coming, and you see how we're going to pass this in. So we're going to bring in feature scaling, and we're also going to bring in model predict. So these are the two blocks we'll be interested in. So for feature scaling, we're going to specify everywhere that was scaled, colon, comma, colon, and for the weights that we stored was feature scaling underscore weights. Then for model predict, we're going to select which model gave us the highest accuracy. Let's confirm. I think it was the random forest. So random forest. So let's select the random forex model, and we'll click on run save. So again, there are models, so we'll give this some time to save. So model predict successful. So pipeline, you want to take into cognizance of those functions that are very germane in editing the structure of your data set, that stores weights basically, and each of these guys stores weight except the drop column. So drop column, very important. So the same way you've modeled your flow on the project, the same way you come model it here. Yes, so feature scaling, the model predict. So we'll navigate back. Beautiful. We've navigated backward, and then we can select the predict, and this time around we can select pipeline, and this time around you can see we have more than one pipeline. We have the studio pipeline data set, which we're interested in here, and we can test this out. And to test this out, let's quickly create a test data set. So I'll copy this, and I'll just generate a data set, one dimensional. I'll copy this, then I come back here and paste this and run this. I'll give this some seconds. I'll give this some seconds to run. Beautiful. So this ran successfully, and if we double click on the YPRED, what did we get? 46.3.86, and in which this is 46.3.26. Beautiful. So we've just successfully built our first studio pipeline. Yes, I will run us through some more examples so you can really understand and digest it. And so if we open the logs to look at the pipeline logs, I needed to notice some things. So firstly, the data sets using the weights, so the model weight saved there, and this DP5 happens to be random forex regression predict, okay, and it picked up weight here using the parameter of all and all sample to be used. This is what we passed, and model predict. So if you notice, the item has been scaled. So this particular guy scaled the data set, and this is now the model predict. This guy was the guy to scale the data set from what we specified on the pipeline, and this other guy was the one to, you can see this is the scaled data set, and this other guy was the guy to take the scaled data set and perform a model predict leveraging the model that we've assigned to run that particular prediction. And you can always hover back to come update the exact model and click on save. But yes, we'll leave this for now. And beautiful, we're able to build our first pipeline. So we would do a couple of comparison between both projects. So 1 second, let me copy the data set and have it here opened. So we'll do a quick refresh here, and this happens to be here data set 2, and we have 2 pipelines here. So this is for Studio Wizard and this is for Studio. So let's run an inferencing on this particular pipeline. I will run this. Around this, I will got 46.1.11, and yes, and this is supposed to be 46.3.26. So the random forex algorithm performed better, but yes, that is just for that particular record. We can select more records and run some more inferencing. Let's select a random record. We can select this. Okay, and the first thing we need to do is to create a data set, paste this here, select one dimension, and we'll copy this, and let's run this. We'll run this on Studio Wizard first, and we got 43.97. and let's run it equally here, and I got 43.2.76. I've forgotten the first one. 43.2.76, and this was for studio, and this is 43.5.97, and let's see who got it. Okay, 43.2 was for studio and 43.5 was for Studio Wizard. Yeah, so Studio Wizard was actually closer. Both of them performed very well. Both of them performed very well. But yes, we have a better accuracy from the accuracy validation from the Studio Wizard model. Yes, for this particular data set. Yes, so we'll run one or two more, then we'll go inference it via the API. Then yes. Okay, let's run this. We'll run this. We'll create scalar, one-dimensional. Okay, I'll copy this. Let's paste this here. Okay, beautiful. The right prediction here is 447.02. And let's test it out with these two models. So we'll start with the studio model this time around. I'll paste the dataset link, and 447.02, and the studio model gave 447.92. okay, that was very close. And then let's run the Studio Wizard model. 447.92, 448. So the studio model, which is random forest, had a better accuracy here again. So beautiful. And so we are going to run tests via the API, via the Postman environment, and see how very easy it is to integrate. All we need to do is we click on project, we select this particular project, and we can see pipeline. So we have two pipelines. We can use either of the pipelines. So we start with the studio pipeline, and we open this, and we change the flow ID here to that of the studio pipeline, and we need to change the data set here to that of the studio pipeline. As simple as that, and beautiful. Whenever you are going through the studio route, all the data preprocessing steps that you've brought into the pipeline is going to be visible down here. Yes. So on the Studio Wizard, it happens automatically, so you only see one log result. But for studio models, if you run very complex model with very complex data preprocessing steps, you'll see, and you bring each of those data processing steps on the pipeline, then you see the logs for each of those pipeline blocks. Okay, so yes, you can see past the sample data to be used, and this guy feature scaled it and ran successfully well, and it passed the feature scaling data set using this model. So here was using the weights of the feature scaling and the boundaries of the feature scaling where it's supposed to be applied, and the data sets. And here you can see using the model of the feature scaling, using the sample data set to be used, which was the output from here. And yes, converted to flow 32, ran model predict, and model predict successful. Visible, and beautiful stuff. You can do on Autogon AI platform. And yes, let's look at the result of this, which is the prediction URL. We'll fire this down, we get 447.92, similarly to what we've gotten. And then to use the second pipeline is as simple as selecting data set 2 pipeline, which was actually the Studio Wizard pipeline. And all we need to do is just change the flow ID, as simple as that. And you can see exactly as I told you. And then if you click on this and run this, and this is beautiful. And you can always generate any code, either a PHP code or a Node.js code or a Python code, and very easy. And you can always call the generate data set and passing data set you need to pass. So you get data set in split seconds, and you pass that data URL to this to run your inferencing. Okay, so I'll leave the other two data sets for you to play with, and yes, you can always drop your comment on the comment section, and play with beyond this, play with some much more data sets. We can see these two data sets have small records. You can bring in some more data sets with more records. You can see this is 9, and here you also want to play with the polynomial linear regression. Here you need to bring in one-hot encoding. You need to one-hot encode this particular region. Yes, beautiful. And then let's look at data set 4. You can see years of experience and salary. This is a simple linear regression problem. But yes, the data set is equally small. But yes, so whenever you are playing with small data sets, you get to have very funny error margins and accuracy values. But yes, play with this and drop me comments on the comment section. Okay. Pipeline creation, model inferencing, Autogon quick predict, and Postman. Would I just say we've just covered this? Okay, so I've showed you how to create pipeline, and yes, we're still going to play with more projects, and you'll see the whole thought process of creating pipeline. It's very simple. Model inferencing, yes, when you take a test data and you pour that test data against your model and see the predicted value that your model is going to return. Autogon quick predict, yes, we've been playing with Autogon quick predict, which is actually this page, and we've run several predictions. And on Autogon is a 3-step process. It's different from creating. You can create a sample data set. Yes, a 3-step process. You select the project, you select the pipeline, and you impute the data set link. And if you already have a saved data set, you can select the exact data set and run it. If you run a data set that does not relate to the model, you get an error. Like this is a sample, you get an error. There is a mismatch between blah 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 blah. You just get an error. As simple as that. So you have to ensure you are running the data sets that is required, and always ensure that data sets you are generating for prediction, you can see the way I copied it. I avoided the last comma with the last value, and why is this? Is because the last value happens to be the value of interest, the target value, which is the dependent variable. That's the name for it. So I avoided this because we are trying to predict that particular value. So, and I used all this other value and inference this with a model to get this. So the goal is you've built a model to understand the relationship with the independent variable and the dependent variable. So that model listens for a new transaction. Even when a new transaction comes in that is not available in the existing data set, from the knowledge it has built already, it can predict if that transaction, the amount for that new transaction, or if it's going to be a fraudulent transaction or not, or whatever. Okay. So yes, you can see we train our model, build an interesting network, and inference our model. Okay, so classification. So if you've gotten to this phase again, well done. So we'll be looking at a couple of classification algorithms, like the logistic regression. And some of you will be wondering, classification, why does it have regression? Yeah, it's a classification algorithm. K-nearest neighbor, support vector machine, kernel SVM, naive Bayes, decision tree classification, random forest classification. Yeah, so random forest has the regression, has the classification, decision tree has the regression, has the classification. They'll also be looking at automated machine learning classification. And we're going to do all of this again for Studio Wizard, and we'll do same thing again for the studio environment. And just a quick scan through on when to use each classification algorithm. I'm super pumped. I'm super excited for the beautiful stuff and the beautiful knowledge and how you're going to apply this knowledge into solving day-to-day problems. So logistic regression for binary classification. Binary classification. Now the target variable, yes or no, yes or no, true or false, male or female. Those are binary classification when it's just between two, fraudulent, non-fraudulent. Logistic regression outshines itself. So a decision tree classification for binary or multi-class classification. Yes, random forest or binary or multi-class, and then you can also read the extra info. So you can see support vector machine for binary. So each of these algorithms have their strengths. So you can see this image to the right, purchased or not. So age, estimated salary. Let me try to bring it up. Age, estimated salary, and purchased. And you can see the purchased true or false. So 0 means not purchased, 1 means purchased. Yes, so this is a binary classification problem. So meaning this can work with most of this regression problem. But however, there are some classification problems that are strictly for text. Yes, like the likes of knife buys for text classification, like spam or sentiment analysis, when simplicity and efficiency are key, when feature independent assumptions hold. Yes. So we are going to play with naive bias once we get into the NLP session, and and there are some other algorithms that shines themselves when it comes to image text classification, and yes, beautiful stuff. Okay, so we're going to look at the data set, and we'll start first on the studio wizard for each of data sets, then also jump on the studio environment for each. So you can see this is dataset 1. What we simply do here is we open dataset 1 and we also bring in every single thing to the portal. Oh, this is a whole lot. Let's bring this to the portal and create dataset, and we'll paste the link and we'll call this what name do we give it? I'm very bad at naming it. I don't know. Classification section 4. Classification data 1, that's D1. Beautiful. Okay, and we create these data sets, and let's visualize our data set. Beautiful. So our data set has records of different individuals. Look at their age, their job, marital status, education, default, if they defaulted, balance. I think this is a loan or deposit. This is a bank data set. Balance, do they have a house? Yes. Has he collected the loan? No. Contact, unknown. Day, month, duration, and kindly pay attention on how that data preprocessed. The data set has been preprocessed already to split out day, month, and duration. Yes, so you can leave day, month, duration as a whole together when you're not very interested into the behavior of the customers based on each day, each month, and each year. Yes, so splitted like this, the model is going to dig deeper on and take each of those things as constituents. Okay, so campaign, P days, previous, outcome, and deposit. So this is a binary classification problem where deposit happens to be yes or no. Okay, so we'll create a project for this. So let's quickly create a project for this, and again here again with name S4 classification. What again? Dataset 1. Beautiful. I remembered. Okay. Okay. So let's launch the Studio Wizard environment, and we'll select datasets. S4 classification dataset 1. Okay. We'll give this some seconds to run. And while this is running, we can also open this same project, open the studio environment for it. Yes, we'll run some of these things simultaneously. So same project, we have the studio wizard environment open for it. We have the studio environment open for it. Good. So this is the dataset analyze view, and yes, we can see important. We can see number of missing values. Okay, all clean. Next. So this is a classification problem, yes or no. So good. We will select classification and deposit, and we'll put P deposit prediction of deposit underscore model, and we hit the almighty train button. Bish. Okay. Okay, noted. So while this one runs on one side, let's drag the data input block on the studio environment, and we would open the dataset X4 classification D1. Click on this function block, select CSV and input the file URL, and we run this. Let's check if this is okay. This is still running. Data input has been imported. Okay, so now you look at the data sets. So different data sets, according to the pre-processing steps you're going to do, just varies. So now if you look at this, if we're going to go the man, I like this data set. We need to encode the job. We need to encode the marital status. We need to encode education, and the job, we need to one hot encode job, one hot encode marital status, one hot encode education. Default, I don't know how many columns are there. Balance housing, we need to encode this. This is going to be label encoding. Loan has to be encoded. Contacts, month has to be encoded. Outcome has to be encoded, and yes, and this beautiful. So you can see our studio wizard is done running, and it has an accuracy of 0.8525, which is beautiful. With, you can see feature of importance as regards the target variable, the duration, balance, day, age, PDs, especially the duration. Let's even look at the data set. What's up with this duration? Yeah, this duration is of high significant importance to the target variable being deposit. Okay, so we need to do this manually here. So we're going to go two routes. So the first route we're going to go the manual route of pre-processing, then we'll go the automated route of pre-processing. That's for data pre-processing here. And the manual route will pre-process this. And why I want us to go the manual route, it's so our pipeline can be much more robust, so you can understand what we're trying to do. So yes, so the manual route, the first thing we're going to do first is to separate independent variable from dependent variable. So I'll drag in feature sampling, connect it to the data input. This is going to be a long project because of the manual route. And yes, it's very important. Sometimes you need to go the manual route. And we specify colon, comma, colon, -1. And here, colon, comma, -1. And we'll run this. So good. So this has splitted independent variable on one side from the dependent variable. So we have the independent variable here, and we have the dependent variable, yes or no. Beautiful. So the next thing we're going to do is we'll take it one at a time. We need to encode column 1, we need to encode column 2, and we need to encode column 3, and some more other columns. So yes, so let's handle data encoding. and we bring in data encoding. And the thing about data encoding is you cannot you cannot apply data encoding to more than one columns. Yes, so meaning we have to have multiple data encodings targeting each of those columns. Beautiful. Let me keep this neat. This should be neat because it's going to be a long project. So we connect data encoding to feature sampling. Okay. And what kind of encoding? Let's look at this. We're going to start with the first item, admin, technician, services. Because it's more than 2, it has to be a one-hot encoding. So one-hot encoding, and we are working with the X variable, pass through, and what column is that? Column 1. And we specify column 1. Then the name, we need to save it. You can see, so all the blocks that has to do with save name, load name are blocks that you need to pay special attention to because you're going to need them when you're creating pipeline. So we'll call this data encoding underscore, let's check, underscore what? Admin is what? Is it job? Underscore job. Underscore job. Yes, you have to be very clear with your naming conventions. Okay, so we'll give this some seconds to run. Beautiful. So let's look at this. Oh, so we can see actually there were multiple jobs. Okay, so the job region has been encoded. Good. It was up to 1 to 12, about 12 different types of job. Okay, so we need to encode column 13. Then after column 13, we encode column 14. So yes, we want to encode column 13. So let's bring in data encoding again. Just bring in another data encoding. So this is going to be for column 13, but we give it the actual name. Let's do column 13 first. And this is going to be a one-hot encoding, X variable, pass through. Let's look at the name of column 13. Column 13 has to do with marital status. Yes, marital status. Then the next one is education. So column 13, data encoding underscore marital, and run this. Okay. Beautiful. And you can see our data set is getting much more wide. So column 13. So now we need to encode column 16, which has to do with education. So we'll click on this one-hot encoding. Let's be sure that it's one-hot encoding. Secondary, tertiary. I don't know how many columns are here. So there's primary. So it's more than 2. Yes, we need to one-hot encode. If it's 2, label encode. So one-hot encode, X variable, DE underscore education. Pass through. I've forgotten the column. And this is column 16. And this is 16. Okay. So connect this to data encoding. Okay, and we'll run this. So take notes, data encoding, another data encoding, but you can see there are different save names and different column indexes that it's actually targeting. So let's now look at the output of this other data encoding. Beautiful. So for this, so we will do 2 more items. we would, okay, we need to encode this yes, no, column 22, column 20, okay, column 20 first, column 22, column 23. When we're done, you will appreciate the you appreciate the power of automation. Well, yeah, so we'll do this also using the automated data preprocessing. So we need to encode this, encode this, encode this, encode this, and encode this. Exactly. Okay, so don't be scared about the structure. So I took a pause. We stopped here at the data encoding, the third data encoding, in which we did data encoding for education. The beautiful thing about it is when you highlight any particular stuff, you can see the equivalent variables, which you can go visualize this. So now I took a pause from the video and I did all of the data encoding. I'm going to run us through all of this, and then we'll go to the point of the data splitting. After we're done with all data encoding, data splitting, feature scaling, then we dragged random forest classification, random forest prediction, random forest classification metrics, same as the automated classification metrics. And we built the equivalent of going through all of these data encoding routes by calling these simple steps. From drop colon, because we called in a drop colon here, to automated data preprocessing, to feature scaling, random forest, and we built all of this. So yes, I can run you from where we stopped together. So data encoding, we did label encode index 20, and the index 20 here happens to be index 20. Yes, we did label encode index 20. It was a no, yes, no, yes. Label encode. Yes, that's why we used label encoding. Then we encoded the housing section, was index 22. Then we encoded the loan section, index 23. Then drop colon. Yeah, we had to drop colon. So 2 items needed that drop colon, and that was like the contact. So we dropped colon of contact. Let's quickly open this data set. We're having unknown at index 24 and index 31, so we dropped them. Yes, so we don't pollute the accuracy of our model, so we dropped those column offs. We dropped this column off. So that was drop colon. Then we encoded the month, and yes, we did one hot encoding, and we encoded a month variable, month column. And as soon as we're done with the month column, we called in the data splitting. We allocated 20% of the data sets to the tests and 80% to the train. And after this, we called in feature scaling. So feature scaling, so let's open data splitting. So if you see the X train, so good. So how to scale index 0, how to scale index 21, or how to scale index 24. Yes, beautiful. So feature scaling 0, 21, 37. Okay, let's check what is in 37. Okay, and 37, yes. So we scale 37. Okay, we did not scale 24, yes, and 37, yes, good. So after scaling those region, then we went ahead to build the random forest classification. So I think we also even need to scale the 27. The 27, yes. That's the 1 of 5. I think this was this data splitting. Yes, we need to scale 24, index 24, column 24. Yes, you can play with it in your own project. So now then we went ahead to build the random forest classification. Random forest classification, we use criterion of Gini. I'll pass random forest classification, and when we're done building the model, we predicted the X tests. Like I've told you, the predict is always going to predict X tests. So you can see X train our model learns the relationship between X train and Y train. Then this is now the test set. So our model is going to predict the X test to get the Y test, but it's going to generate a variable called YPred. So you can see there's now a YPred. So our metrics is going to be calculating the the Y test and the YPred and check how accurate our model is. Yes. So so we did the prediction and then we checked for metrics, and our R2 we got a 0.58. Beautiful. That's approximately 0.6, but don't forget we got a 0.85 on Studio Wizard. Okay, then yes, we went through the classification, automated classification, and specified a total wait time of 150 seconds and 30 seconds to run each algorithm maximum, and yes, we call this calm, and we predicted the X test to get the Y test, so we're going to get the YPred, and if we click on this, yes, we got an accuracy of 0.54, and this is just lower than what we got for the random forest. Okay, so there were some small issues like the data splitting, a colon that was not feature scaled, and some small errors you might not catch very fast. So going through the automated data processing, it takes care of those errors and even does some data cleaning for you automatically. So I called the drop colon, and I dropped the contact and one other item that had the unknown. There were two columns like that. Then I called automated data preprocessing, and here I passed this slice boundary that's going to split independent variable from dependent variable, and here, so mean missing value, used mean test size 20% to test, then one hot encoding. So I had to specify 18. The default here is 10. And why did I specify 18? If you look at the data sets, this job category is more than 10. So I specified 18 because I ran the automated data processing, and here was not one hot encoded because the category was higher. So I had to specify 18, and it captured it in its scope, and yes. And so I entered the name of the weight to be saved for the automated data processing, and ADP underscore weight. Beautiful. So feature scaling. So yes, we applied minimax scaler on the X train, and did fit here and use it to transform the test, and we scaled. Okay, let's go visualize automated data processing. So you always have to select here, and so it shows you the highlights. So if we open X train, so you can see we had to scale column 0, column 5, and column 10. You can see how automated data processing even still, you can see the way it's broke down the job from admin to blue collar to entrepreneur to housemaid. Yeah, it broke it down in a beautiful manner. Okay. So yeah, we called in the feature scaling, and we applied it on these various columns here, and when we're done, we went ahead to call the random forest classification, same criterion, and passed this, and interestingly we got an accuracy of 0.79. That's beautiful. Yeah, that's beautiful. So, and this was a significant boost of this other random forest that had accuracy of 0.58, and this one has an accuracy of 0.79. This is how important data preprocessing is to an AI model. So if you preprocess it very well, you achieve better accuracy. And we can here we used only random forest classification. We can play with some more algorithms, and also we can play with other criterions. Here we're using Genie. You can play with other criterions, read the documentation, and we can play with other classification algorithms, and we can achieve even up to 0.96, 0.99, as beautiful as that. So this is the flexibility the Autogon Studio environment gives you that Studio Wizard doesn't give you. But Studio Wizard on the fly can build a high accurate model in which you can achieve this on Studio environment and even higher if you know how to manipulate your way around your data preprocessing and play very much around your criterions using different algorithms. Okay, so we're going to go ahead and build a pipeline. So first we'll build a pipeline for the Studio Wizard model. Then we'll now build a pipeline for two pipelines we're going to build from the Studio model. We're going to build a pipeline from this long chain, and we'll build a pipeline from this other chain. You see how beautiful this is. It's quite beautiful because there is no limit. You can keep adding. The canvas is very wide. There's no limits to what you can do on the Studio environment. You can build, preprocess. You can branch out another chain from these data inputs and have another chain and build. And the beautiful thing is, if you want to rerun this entire block, if you click on this and click on this run blocks, it's going to run it one at a time till it runs to this end. So just peradventure you've made an update here, you don't need to run one. You can just click on this first one and click on the run block, and it runs every single thing on that particular chain. Yes, if you do same here and you run this, it's going to run the first chain that it's aware of. But if after you've run this, you can click on this and click on run all blocks, and it will run this particular chain down to the end. The beautiful thing and the power of the Autogon AI Studio environment. Okay, so let's quickly navigate towards building pipeline. Okay, so we can see from the Studio Wizard interface, we can see all the models. So this is from the Studio environment. This is from the Studio environment. This is from the Studio environment. This is from the Studio Wizard environment. We had a 0.85, that's 85% accuracy for this model from the Studio Wizard environment. We can just go ahead and create a pipeline here, and we'll call this Wizard pipeline. Okay, I will create this pipeline. Beautiful. Okay, so our pipeline has been created. We can now go to project details, and we can see the Wizard pipeline here, which is actually beautiful. So now let's navigate to the Studio environment, launch the Studio environment. Now we have this Studio environment open, and we are opening another version of it, and I'll tell you why. And this is because we're about to create two pipelines, and the data preprocessing phase, especially for this chain one, is actually very lengthy. So I like to open it on two sides so I can be watching what I'm doing. So if we click on this, we'll create Studio pipeline 1. Yes, Studio pipeline 1. Okay, so we've just created this pipeline, and so we are going to start first with building a pipeline for this flow. So feature sampling. So we'll start with the data encoding, and then we import the weight DE job. Before we begin to import the weight, if I click on model and weight, we can see we have all the weights and all the models built. So yes, and all the weights, and here we have all the models built. Beautiful. So we'll come here and we bring in data encoding, and the first weight we're going to select is what? DE job at index 1. So yes, we'll select. Let's quickly replace this index 1. I will select what? DE job. Okay, so the second weight we're interested in is DE marital at index 13. So we drop in data encoding again, and we're going to map it DE marital at index 13. So we drag in data encoding again, and the next we're going to use is DE education at index 16. We'll connect this, and this is going to be DE education at index 16. The next one is going to be DE defaults at index 20, and then we'll drag in this, and this is going to be DE defaults at index 20. Okay, beautiful. The next is going to be DE housing at index 22. So we'll drag in data encoding again, DE housing at index 22. The next one is going to be DE loan at index 23. DE loan at index 23. The next is going to be drop column 24 and 31. So connect this, and this is drop column 24 and 31. And the next is going to be what? DE month at index 25. So bring on that data encoding, you see, as beautiful as this. DE month at index 25. And the next is going to be data splitting. This is not needed. Feature scaling, we'll bring in feature scaling at this boundary 0, 21, 37. So bring in feature scaling, and we'll connect the feature scaling with, so just to be sure, feature scaling underscore width, because we created multiple feature scaling underscore width, and we'll paste this. And between this model and this model here, we had high accuracy here. So let's check this. This was a 0.58, and this was what? A 0.54. Okay, we had high accuracy here. So we're bringing in this model name, CAML. So we'll drag in model predict, and we'll select the model CAML, and we'll run save. You see, was it easy? It was very easy. You just have to be careful and ensure you follow the entire flow, the process properly. And so this is so it's an interesting project, very interesting project. Okay, so while this is happening, we're going to create another pipeline, and the pipeline is going to model this other flow. And we'll start by bringing in the drop column, then we'll bring in the automated data processing, then the feature scaling, then model predict. So this is going to have 4 flows. Yes, so feature scaling successful and model predict successful. So we're done with pipeline 1. So we're going to create another pipeline, studio pipeline 1. So we'll call this studio underscore pipeline 2. I will save this. And if you look at the project, so it starts with drop column. So we'll bring in drop column. So drop column at index 815. So drop column at index 815. The next item is going to be what? Automated data preprocessing. Automated data preprocessing. We'll bring in automated data preprocessing. And we'll select add X and automated data preprocessing. Good. So the next one is going to be feature scaling, and feature scaling at 0, 5, 10. These are the boundaries. Feature scaling 2_weight. So bring in feature scaling, feature scaling 2_weight, and these are the boundaries. And the next is random forest classification. So we just bring in model predict, and this is the model we're going to select, random forest regression 2. So we'll bring in model predict, and then we'll connect it to random forest regression 2. Then we'll run save, and this is beautiful. We have just created the second pipeline. So yes, you can have a project, and a project can have multiple pipelines using the studio environment, and each pipeline carrying out whatever data processing task that is needed of it. So feature scaling, and it remains one more. You can see model predict, and this is beautiful. So we are done creating our pipelines, and yes, we can come back to our project, and this is beautiful. So we're going to create a test data, and this test data, we're going to try it on all the pipelines. So you can see this is wizard pipeline, this is studio pipeline 1, and this is studio pipeline 2. Studio pipeline 2 has about 0.78 accuracy, and this has a higher, the wizard has the highest accuracy. Okay, so we will click on quick predict. Beautiful. And we select these, and yes, we can begin to navigate, play with our pipeline. So let's come to the data sets, and let's select all of these rows, all of this independent variable, because the goal is to use this independent variable to deduce the dependent variable, yes or no. And okay, we can replace this, and we will select the wizard. Okay, let's create a data set first at 1 dimension, and paste this data set here, and run this, and beautiful. Studio Wizard said predicted deposit to be yes, and deposit is actually yes. So let's run this again as against pipeline 1. And pipeline 1 predicted this to be yes, and pipeline 1 was the one that had a very long chain, and actually yes. So let me show you the pipeline logs, and yes, you can see it's actually beautiful. So from using this weight, each of this data encoding weight, and applied it on index X, index 1, and this was the data set. Then using the weight again, applied it on index 13, using another weight again, applied it on 16. So each of those data encoding had their various weights, and you can see all up to the model predict, which is actually beautiful. So yes, one of these has to do with feature scaling, which is actually beautiful. Okay, noted. So let's now try this on pipeline 2, and run this, and we got a yes, which is 1, and this is also very beautiful. So now let me tell you why we got a 1. So yeah, we got a 1. So let's hover back. Yes, so we got a 1 here because the Y test has been encoded already, which when we did it manually, we did not encode it. So the Y test has been encoded, that's the Y value was encoded and splitted. Yes, so so it was actually label encoded. So and yes, and that's why we got a 1, and 1 signifies yes. So beautiful. We succeeded in building an interesting model, and this was a model. Yes, it's really an interesting model from this dataset. And yes, our Studio Wizard model came up with the highest accuracy. So I'll show us how to quickly use this to run a quick prediction using our Postman environment. I'll quickly pop up the Postman environment and I'll place a sample dataset. And changing pipeline is as simple as selecting the project, and you can see the 3 pipelines. Taking Studio Wizard pipeline, that's the flow ID, and we update this flow ID here. I will send this, and you can see beautiful. So when you see just one prediction log like this, it's actually a Studio Wizard. And if we visualize this response, we'll see deposited yes, which is beautiful. Quickly close this to save some space. Okay, so and if we go again and run a prediction using pipeline 1, all we need to do is to change the flow ID, and we'll run a prediction, and we're going to see very long logs, and you can see beautiful. So you can see all of those logs we saw, and if you click on this, you would see we're having a yes, which is beautiful. And same thing applies when we copy this, but we're going to get a value of 1, and 1 meaning yes. And you can see, but the log is not as much as the one that we did all of it manually. And yes, automated data preprocessing bundles so many things for you and does so many things behind the scenes. So 1 signifies yes. Okay, so we are done with this particular data set, and if you built this project with me, clap for yourself, and cheers to you. Okay, and so we're going to be looking at the dataset 2 and dataset 3. So dataset 2 and dataset 3, I hopefully is not as interesting as dataset 1. And so we can see this. Let's exit dataset 1, project 1. So you can see I ended up building a very beautiful model. And yes, okay, so and we can see dataset 2. Let's quickly import this dataset 2. So S4 classification dataset 2, S4 classification D2, and we paste the URL here. I will copy this and update the description. Beautiful. And if we visualize dataset 2, good. So if we notice something here, so we can see that sample code number, clump thickness, uniform of cell size, cell shape, blah blah blah. This happens to be, I can see mitosis, biological data set, and this class now varies. So good. So you can see there's a 2, there's a 4, and okay, so we are going to start first by creating a project. We're going to create a project that models that solves this problem. So we'll quickly get to project, and we'll create a new project. So this one was S4 classification D1 and X4 classification D2, and we'll create this project, and we'll launch our Studio Wizard again. Select existing data sets, select dataset 2, and we give this some seconds to run. Okay. Okay, I like to check the number of rows. Okay, 682. Okay, noted. So if we look at this, we will notice something. You guys can see what we're trying to predict is actually the class. We're trying to build a data set, a model that understands the relationship between the independent variable and the class. Exactly. And yes, so that's what we're trying to do. So let's look at missing, number of missing, nothing is missing. So this importance is an importance that is not dependent on the target variable. So yes, we'll see feature importance after the model has been built. Good thing. Okay, so we'll select next, and then we'll select classification, and we'll select the class, which is what we're trying to predict, and we'll call it p class underscore model, and we hit train. So while this classification model is being built from this dataset 2, we can already launch the project and open studio environment. Yes, studio environment. So it's very important you understand how to build equal projects, solve same data needs on the studio environment also. Oh, beautiful. We have a 99% accuracy. A random forest classifier came up with this 99% accuracy, and this is beautiful. You can see all the magic is just done on Studio Wizard environment. Okay, so we will drag in data input, and then we're interested in data sets S4 D2. Let me zoom out. Good. And I'll select the CSV and I'll paste this. Hopefully we are not getting to do much data preprocessing on this particular data set. Okay, so clump thickness, uniformity of cell size, and every single thing. So we're interested, we're going to separate the independent variable from the dependent variable. We're going to bring in feature sampling, and we'll drag in feature sampling, and colon comma colon -1, and this is going to be colon comma -1. I will run this. Okay, beautiful. And the next step we're going to take is simply, let's look at the data set. So we would need to actually scale this guy, but before we go ahead to scale this, we'll bring in data splitting. So let's drag in data splitting block, drag data splitting block, and give it a 0.2, and leave this data 0, assigning 20% to the test set. So while this is running, so if you look at the variables, you can see it has been splitted already. The next thing we're going to do is to bring in feature scaling. So connect feature data splitting to the feature scaling, and we select the train and the test which we're interested in, and we'll bring in min-max scaler. So if we look at what columns do we want to scale, we can just specify everything. Let's scale every single thing with the min-max scaler column. Yes, and feature scaling underscore weight, Okay, so the next thing we're going to do is to bring in the random forest classification. Drop this random forest classification predict, we'll drop this, and metrics, we'll drop this. Okay, we'll connect this, and we connect this. So we click on this and say random forest classification RFC for a genic criterion. Why this is running, I'll give this RFC. I'll select the default and we'll run this, and good, beautiful, and we'll pass the RFC, which is the name of the model here again, and behold, we have our metrics. This is beautiful. So we have an accuracy of 0.97, and here we have an accuracy of 0.99. Yes, can we tune this hyperparameter to bring the accuracy up? Yes. Okay, so that's going to be your own assignment. You play with that, tune the hyperparameter, play with more criterions here, further play with your data sets, pre-processing. Okay, so we are going to go ahead to build a pipeline, and our pipeline here is going to be simple. The only thing we need to bring in is the feature scaling. We don't need to do anything on feature sampling. We don't need to do anything on data split. We're going to bring in the feature scaling and apply all and model predict. So feature scaling and model predict. So I'll quickly type pipeline. So just one pipeline we're creating, and we'll drag in the feature scaling and we'll drag in the model predict. So we'll connect these two blocks together, and we are scaling everything. We'll select this model predict, and the model is RFC. Okay, and we run save. Okay, so it took us how many minutes? About 2-3 minutes to build a model with a very high accuracy, both on Studio Wizard and the Studio environment. Both environments are for Genius. Okay, so we have the Studio pipeline created here already. So let's quickly create. So if you check the accuracy, you can see there's a 99% accuracy, which happens to be for Studio Wizard, and the accuracy for the Studio environment. So if we select this, we have our pipeline, and we'll call this wizard underscore pipeline, and we'll create the pipeline. Beautiful. And we can then go back to project details, and we have 2 pipelines. Beautiful. So okay, so we are going to try out the both pipelines. We're going to try out Studio pipeline, and we're going to try out Studio Wizard pipeline. So I just done a recreation of the Studio Wizard pipeline. Yes, and let's quickly try this out. Okay, I will copy this. We're trying to predict what is target variable, what's going to be the target variable. I'll create a data set. We select one dimension, and we generate this. Beautiful. And we supply the dataset link that was generated, and we run this using the Studio Wizard, and we got a class 4, which is beautiful. And if we select the Studio pipeline and we run this equally, we get a class 4. This is beautiful as well. And we can take this down to the Postman environment. All we need to do is to replace the datasets. We replace datasets, and we copy the ID. Yes, so we've created several pipelines here, and this is the pipeline for the Studio environment. We'll copy it, and this is the flow ID. And when we run this, I can see how many milliseconds, 9 to 8 milliseconds. And then if we check the prediction results, and what did we get? We got a 4, a class 4, which is actually correct and accurate. So let's run similar stuff for Wizard New. And we'll pass Wizard New flow ID. We'll update the flow ID we have here, and when we run this, we get our prediction URL, we open the prediction URL, we get a class 4. This is actually beautiful. Okay, so this is the end of dataset 2 classification, and we're going to be looking at dataset 3. And yes, let's have one quick peep on dataset 3, and you can see dataset 3: age, estimated salary, and purchase. So what we'll simply do is we'll bring this to studio environment or to Autogon environment. We'll create a dataset. We supply the URL, and we'll call this S3 S4 section 4 classification dataset 3, and we take the same name and we use it here. Beautiful. And let's visualize this dataset. So we can see age, estimated salary, and purchased. Oh, we can see something here that the number of rows for this dataset 3 is 399. Not so much, but yes, we'll make use of it. And we can see, yes, this is the target variable. So the company is wanting to understand the relationship between the age and the estimated salary in line with the target variable purchased. So so they can use this past history, build a model off of it, and be able to predict new customers when they come on board based off their age and their estimated salary. We'll be able to predict if they're going to purchase the product or not. Beautiful. So we're going to dive quickly by creating a project, and the project name is going to be S4D3 and the description S4D3. Okay, beautiful. And yes, we're going to launch this dataset. 1 second. Let's have the dataset opened also. Okay, so we have this opened, S4D3. So we're going to launch Studio Wizard. I also want us to launch Studio for this project. Yes, so we build simultaneously on both ends, which is actually a beautiful thing. So S4D3 section 4 dataset 3. So select datasets for Studio Wizard. We select S4D3. We give this some seconds to run. And beautiful, super fast. And number of missing values all 00. Beautiful. And you can see this is a categorical variable purchased. And yes, we're going to be engaging with this. So I'll click on next. We select classification, we select purchased, and then we'll do P of purchase. Purchased underscore model, and hit the train button. And why these trains? On the other side, we're going to drag in the data input, and then we'll click on data set, and we'll copy this, hit on this, and we click on run, and then we get our accuracy, which is actually beautiful. And so you visualize your data sets, and okay, so the next thing we're going to do, we're going to separate the independent variable from the dependent variable. So we'll bring in the feature sampling, and then we'll map it to this, and what it is going to be: colon, comma, colon, -1. Beautiful. Colon, comma, -1. Much more beautiful. So now we have these values. So good. So what we're going to do, we're going to call the train test splits, and we're going to call the feature scaling. So yes, that's the next thing we're going to call. So let's drag in the data splitting, and we're going to drag in the feature scaling. The feature scaling, yes. Okay, so we connect data splitting to feature sampling, and we'll connect data splitting to feature scaling. And yes, we're going to assign 20% standard to test sets and 80% to the train sets. And if you check this has been assigned. If we look at this happens to be number of rows 400, and if you look at X train, you can see 320 having 80% for train, and if you look at S tests, you can see 80. Makes sense. So the feature scaling, we're going to target the X train, I'll target the X test, and we're going to bring in the standard scaler, and we're going to scale everything on that particular data set. So feature scaling underscore width. So while this run, to give this some seconds to run, while this run or is even done running, we can come check out our model, and beautiful, Studio Wizard came up with a 90% accuracy. This is beautiful. So let's look at the feature importance, and you can see estimated salary has much more of an importance in if customers get to purchase or not. Beautiful. Okay, so let's see if we can beat this accuracy. So our feature scaling is done running. Let's see what algorithm brought this up here. So the LGBM classifier. So we would bring in the random forest classification, and like you know, I like to drag in random forest classification predict and drag in the metrics. I just do it once. Connect the classification to feature scaling, connect the predict to classification, and connect the metrics to predict. Good. So we'll call this random forest classification RFC, and we run this. Beautiful. Our model is done building, and we enter the model name, select the default, and we run this again to predict the S test to get the Y pred. I'll enter our model name, and we bring in an R2 because oh shit, this is a classification, we brought in the wrong yes. So random forest classification metrics. So if we ran that, would have gotten an error. Okay, good, beautiful. I'll enter the model name again, and we run this. Beautiful. So let's see, are you ready? Boom, 0.7. So yes, we can further play with the studio model, and one of the things we could do is we'll bring in automated machine learning classification. Things we're having to do with a regression task, we'll drag this guy, we'll drag this other guy, and we drag the metrics. So we'll connect this, and we can already run this 120, and okay, spend 20 seconds per algorithm, and I'll call this automated classification underscore model. We'll copy this and run this. Okay, so while this is running, we can connect the predict to this, enter the same model name, and default. So now, why did we place in 120? So 120 is going to be the total wait time, like I've explained in time past, and 20 is going to be 20 seconds per algorithm that it's going to run. So this particular block is going to run multiple algorithms. Then good, we also connect metrics. So we're connecting all of this. So as soon as this particular block is done running, we will fire down with the predict and fire down with the metrics. So let's give this some seconds to run. Okay, so our model is done building, and there's something beautiful about calling the automated classification or the automated regression. It shows you the sprint statistics, and you can see it's showing us already the best validation score. What did we get here? We got a 0.9. We're getting a 0.9 here as well. It ran a total of 49 algorithms successfully, and yes, okay. We can also look at the leaderboard, and you can see the different algorithms that was initiated, and then we can see the cost as to time it took, and the duration, cost, and everything. and then beautiful. So let's call the predict, and when we're done we will call the metrics. And once we call this beautiful, we'll call the metrics, and let's see if we're able to get a higher accuracy than the Studio Wizard environment. And what did we get? 0.675. So yes, we got a 0.675. So we will not get an accuracy that is higher than the Studio Wizard environment. So one way to go about this now is to go and retweak and tweak our data processing phase again, and look at what we can optimize greatly to beat up the accuracy. So here this is 0.675 and this accuracy here is 0.7, but here we have a 0.9. beautiful. So we're going to go ahead to create a pipeline, and the pipeline is going to have feature scaling and model predict. So the model for prediction we're going to use here is RFC, and the feature scaling is fs_width. So I'll simply click on this, and I'll call this pipeline studio, and we click on this, and two things: feature scaling and model predict. I will select the feature scaling. We scaled the entire item, and feature scaling _width. Select this, pass it to the model predict, then RFC, and we'll run saving. We'll give this some seconds. Feature scaling is done running, and model predict also is done running, and beautiful. We have our studio pipeline fully ready for inferencing. So we are going to create our pipeline also. Yes, I can see this is 70%, 67%. We are going to create our pipeline also, and we will call this wizard pipeline. Yeah, because it's actually a wizard. Yes, beautiful invention by Autogon AI. And so we can see we have our both pipelines, which is actually beautiful. So now we can quickly jump on our quick predict, and we'll select S4 classification D3. I'll select pipeline. Are you ready? Are you ready? So we're going to try this particular guy, 26 and 52,000. We'll try these two independent variables to try to get this dependent variable, and we'll see the guy that predicts it very well. So we quickly create a data set, and select one dimension, generate a data set. We copy this, and let's start with the wizard pipeline. We paste data set link, and we click on run model. And what did we get? We got a 0. Beautiful. And we hit the pipeline for studio, and what did we get? We got a 0. So both models predicted this accurately. So we're going to try another data set. So we'll try to inference this 27 and 137,000. We'll create a data set, supply this for one dimension, generate data set, copy this, and we update the data set URL. And what did we get? We got a 1. And for the wizard pipeline, what did we get? We got a 1. So we have a very interesting model that we've just built from the Studio Wizard portal, and also from the Autogon Studio portal. And yes, we can copy the data set, and we take it straight to our Postman, and we update our Postman URL. Very important. And we'll click on my projects, and we copy the wizard pipeline and update the pipeline ID, and we'll click on inference, and beautiful. When you run this, we have a 1, and this is correct. And if we do equal item also for the studio environment, we're also going to get same prediction value. And this happens to be the end of classification class. You can take your time to scan through all of these. Yes, so slicing, multiple linear regression, and understanding some of the formulas. So these are some added documentation and some build up with some documentation around the images that was placed and data sets for further learning and improvement. Thank you very much. I think I should have said the thank you once I got to the thank you part. Thank you very much, and I see you in the next section. Bye for now.